For more than 50 years, space was primarily a frontier marked by flags and footprints. We went there in those early days, simply to prove that we were capable of reaching those distant places. However, as we stand here in January of 2026, the chapter of merely visiting the cosmos is officially closed. This year is decisively the year of infrastructure, not just exploration. Right now, a colossal mega-moon rocket is sitting fully fueled on a launch pad in Florida. It is preparing to carry 4 brave astronauts on a swift journey around the moon in just a handful of days. Meanwhile, over on Mars, a rover has just uncovered strange, bright white stones, suggesting a million-year history of actual rainfall. And back in Earth's immediate orbit, 2 specialized satellites are engaged in a high-tech game of aerial evasion. They are working together to create a completely artificial, temporary solar eclipse. From the nascent birth of space-based AI data centers to the very first bricks composed of Martian soil, the paradigm has shifted. 2026 is the seminal year we finally stopped just staring at the stars and began actively constructing a home amongst them. This radical transformation is what we call the Great Space Pivot. As we embark on this new age, the entire world seems to be holding its collective breath in anticipation. As of this late January in 2026, NASA has successfully concluded its final crucial system tests for the Space Launch System rocket. The Artemis S mission, which is the first human flight to the moon in over 50 years, is slated for launch as soon as the 8th of February. The 4-person crew, rightfully led by Commander Reed Wiseman, are now beyond mere training simulations. They are meticulously finalizing their exact flight paths for a 10-day deep space voyage. This journey will take them further away from Earth than any human being has ever traveled in recorded history. Yet, Artemis II represents so much more than just a quick lunar flyby for photo opportunities. It is the ultimate stress test for the Integrity System, which is the Orion spacecraft they will call home for the duration. This critical mission will definitively prove if our complex life support systems can effectively handle the harsh deep space radiation of the Van Allen belts for an extended duration. A success here clears the necessary path for establishing a permanent human presence on the moon before this decade concludes. In short, we are not merely sending people back to the moon. We are rigorously verifying the hardware required for a truly multi-planetary future. While humanity prepares for this great outward leap, we are simultaneously learning vital new ways to protect our home planet. In January of 2026, the European Space Agency achieved a remarkable technical world first with orbital formation flying. The Proba-3 mission involves 2 separate satellites, flying in perfect coordination, maintaining a separation of exactly 150 meters. This separation must be held with astonishing millimeter-level precision throughout the operation. For this experiment, one of those satellites functions as an occulter, its sole job being to perfectly block the direct light of the sunday. This dedicated shadowing creates a permanent artificial solar eclipse specifically for the second satellite, which is the coronagraph instrument. This unique setup finally allows scientists to observe the Sunday's faint outer atmosphere, the corona, in unprecedented detail, 24 hours a day. The critical importance of this lies in the fact that the corona is the very birthplace of dangerous solar flares. By mastering this complex celestial shadow dance, in the vacuum of space, we can now proactively predict massive solar storms. These storms pose a significant threat to our delicate global power grids and the vast network of orbiting satellites we depend on. In 2026, by learning to create a shadow, we have finally gained the ability to see the true nature of the light. Millions of miles away from our current orbital work, the Perseverance rover has just delivered its most startling finding to date. On the familiar rusty red plains of the Jezero crater, it has spotted something incredibly out of context: a collection of bright white rocks. Initial analysis, quickly processed by advanced onboard AI, confirms these are kaolinite clays, a mineral signature previously thought impossible. On Earth, these specific clays can only form after millions of years of consistent, warm, and sustained rainfall events. This profound discovery, confirmed mere hours ago in this new year, completely rewrites the entire geological timeline of Mars. It strongly suggests that the planet wasn't just briefly wet, but may have actually hosted a stable, rainy climate for millions of years. This single fact makes the ongoing search for ancient microbial life on the planet exponentially more promising. If Mars once had rain, it confirms the existence of a fundamental hydrological cycle, which is a prerequisite for life. Perseverance is no longer just a machine driving across a landscape. It is functioning as an invaluable time machine. It is revealing a world that, billions of years ago, looked surprisingly similar to our own blue marble. Infrastructure development in 2026 is now extending beyond just rocket science. It is all about long-term staying power. This very month, brilliant researchers in India released a breakthrough study detailing the potential for space bricks. By utilizing specific, specialized bacteria found naturally in soil, scientists have successfully bound simulated Martian regolith into sturdy building blocks. The implication is monumental. We can now effectively grow our bases on Mars rather than hauling massive amounts of concrete all the way from Earth. Simultaneously, the private industry sector is making a rapid pivot toward the creation of massive orbital data centers, with major players like SpaceX and XII reportedly exploring strategic mergers. A bold plan is taking shape. The goal is to move the immense processing power required for cutting-edge artificial intelligence directly into high orbit. By harnessing the natural, absolute cold of space to cool the servers and the infinite power of solar energy to run them, 2026 truly begins the era of the off-world cloud. It is becoming very likely that your next advanced AI assistant will not be running in a data center in Virginia, but on a high-orbiting satellite above your head. When we review the sheer scope of progress made in just the first month of this new year, the overarching trend becomes undeniably clear. Space is no longer a distant luxury for scientific curiosity. It is rapidly becoming our next vital laboratory and our future factory floor. We are presently witnessing the most profound transition in our entire history, humanity shifting from a purely planetary species to a truly cosmic one. From the startling white clays discovered on Mars to the artificial shadows cast upon the Sunday, every single breakthrough is a foundational brick. These bricks are laying the groundwork for an entirely new civilization beyond Earth's cradle. If you intend to remain on the absolute front lines of this historic final frontier as this momentous year unfolds, please consider hitting the subscribe button right now. Joining our community ensures you won't miss a single development in this incredible age of expansion. The stars are no longer just distant lights we admire. They are now tangible destinations where we are actively planning to go. Thank you very much for watching this deep dive into the dawn of a new space age.